unit is, in my opinion, not labeled correctly. It should say probability and odds. But even the province will just have probability when it comes to this one. So I'll ask you to add and odds. Okay? I don't know if anybody took the time to read the jokes. I don't know if you caught this. Maybe you're just like, eh. But some funny, yet this is how the math would work. There's 200 million germs in a droplet, in a sneeze droplet, okay? 200 million would be 200 followed by 6 zeros. And it says that hand sanitizer kills 99.99% of germs, right? Which means, what do you need to get to 100, right? 0.01%. So if we took 200 million and multiplied that by 0.01%, what would that be? 0.01, you got to divide that by 100. That's 0.0001. Okay, so let's do the math. Let's do the math. 200 million. We're actually going to do part of this in later sections. Oh, I'm missing a zero, sorry. So there's still 20,000 germs in a droplet of, in a sneeze droplet. So ew, right? Ew, 20,000 germs are still there. Has anybody seen Dumb and Dumber? Anybody watch that movie? No? It's a classic. You should. I'm not going to endorse it because it's kind of stupid. It's kind of a dumb movie, but anyways. There's these two guys that are they're after this one girl, right? They really want to like try to win her heart. And so at one point the guy says, like, what are my chances of us going out on a date? Is it like 1 in 100? And then she's like, I would say it's like more like 1 in a million. And he's super happy. The scene is hilarious. He's like, yes, you mean there's a chance, right? Doesn't understand probability. If you want to see the clip, here's your QR code for some good entertainment, okay? Anyways, let's start our unit officially now. So just so you know, write this down, please. Probability is in general, okay, number of favorable outcomes divided by total possible. This is very important, okay? Total possible. I would box this in. I would highlight the box. This is in a nutshell what probability is, how you stated originally. It's going to be a fraction most of the time, okay? I would say most of the time when you're answering a question, you're going to start with a fraction, okay? So here it is, just a little bit of background check, making sure you understand. What's 1/3? Let's figure out 1/3. So you go 1 divided by 3, right, on your calculator. That gives you 0.333 repeated. This is where it gets a little, if you care about full marks, if you want to get full marks on a question where they ask you to round to 2 decimals, you want to pay attention to this. This is like an annoying piece of this unit. 1/3 on your calculator screen tells you this, right? That keeps going. This is your screen. Screen on the calculator, but that is not good enough. Like, you actually need to round it at one point. If the province said, state your answer as a decimal, what would you do to round this to 2 decimals? What would you do? You would say 0.33. Boom, you get full marks. However, what if the province says state your answer as a percentage? Can you just take this and multiply this by 100 and go 33%? That would be considered wrong. you rounded incorrectly. They want you to go back to your screen, multiply that by 100, right? I multiply my screen by 100, and then I take this answer and round this to 2 decimals. Oh, you can't see that, sorry. So what would that be? 33.33%. Does that make sense? You can't go your previous answer times 100. That is a no-no, right? The only time that would be okay is if your calculator, I'm going to clear my screen here real quick. If your calculator actually gave you this answer, obviously this is your decimal, and then you multiply that by 100, you get 33%, then yes, right? But if this is a rounded answer, do not take that to state your percentage. That's the annoying part. Words. How would you do words? This kind of cheating, low-key cheating. 1 of 3. Or 1 out of 3. I've never seen them. I never seen that they ask you to state it as in words, but these are the 3 acceptable ways of stating your answer. Okay? Can you try that real quick? 2 over 7, state it as a decimal percentage in words, and then we'll move on. So here it is. 2 divided by 7. My screen shows 0.2857, and so forth, right? This is like, imagine this is your screen. If you want to state this as a decimal, what would you say? 0.29, because the 5 bumps this to a 9. Okay? If you want it as a percentage, you take this, you multiply that by 100, and now you round it to 2 decimals. So that would be 28.57%, because the 1 doesn't do anything to that 7. So we call it rounding down. Okay? And then in words would be 2 out of 7. Okay, this is kind of cheating, this other way, but I think if you did this, that would also be okay. So it's not quite all words, but if you do the out of in there, you're fine. Okay? We're good? This table, I think I'm going to hold off on this table for now. We'll do this like a filler some other time. Okay? Let's continue. I want to get into probability. I want you to practice probability. I have mixed feelings about reducing fractions. You don't need to reduce fractions. For the exam, you don't need to know how to do it. If you state it as a fraction, it doesn't have to be reduced, right? If you come from a different course, you probably had to reduce your fraction. The reason why the province doesn't give you marks for it because you have a calculator. Okay, so I'll show you the quick and easy way to reduce any fraction. Okay, let's see this one here. You go 28. I have this button here, A, B over C. This is like a fraction button. If I go 28 and then followed by 42 and I hit equals, it will simplify it for you. So that's 2/3. Some students don't know it, but here it is for you. Please don't bother with it on an exam or on a test, because if you make a mistake, you lose marks. So I'm just going to show you because it's a nice trick to know how to do. Okay? I will also show you the old school way of doing this, like the old school no calculator method. It still requires a calculator, but it's a different step. So here, I'll show you how I do it. If you could take 28 over 42. Especially when I notice that both numbers are even. They both end with an even number. I slice them both in half. So 28 divided by 2 is 14. 42 divided by 2 is 21. Okay? I can't do by 2's anymore. What is a number that goes into both of them? 3? Okay. There's a different number, but I'm going to go with 3 right now. Oh, 3 doesn't go into 14s, right? Sorry. I got suckered in. 7, yeah. 7. What I'm trying to say with this is be careful. Okay, I did it on purpose. Sure. Okay. There you go. So you got to divide both by the same number, and then it's fair game. Then it's fair game. Some of you might have to take a little longer because sometimes you might not find a number that goes into both of them that is big enough. You might pick a smaller number, that's fine, but if you do it long enough, you should all arrive to 2 over 3. Okay? So I'm going to leave this. I'm not going to spend time. I'm honestly not going to even ask you to reduce a fraction, so you're now officially don't have to worry about it. A deck of cards. I do need you to know how to work with a deck of cards. Here is the entire deck of cards. There are 52 cards total. I'll give you a cheat sheet entry in a bit, so just hold on. It's like a business card. You can fit this whole thing in a business card space, okay? A deck of cards, if this is your middle, 26 are black cards and 26 are red cards. So of everything, there's 4 aces, right? Half of them are red, half of them are black. There's 4 twos, 4 threes, 4 fours. You get that? There's 4 of everything. What are these ones called? Jack, yeah, face cards. These are jacks. There's 4. There are 4 queens, except for at home. I only have 1 queen, but anyways. I had to throw that in there. 4 queens and 4 kings. Okay? All together, we've got 12 face cards. So all of these together, the ones that have a face on them, they're called, obviously, face cards. Another thing, you need to know that clubs and spades are considered black cards, and hearts and diamonds are red cards. To be honest, I don't know why it's weird, but I just remember that hearts and diamonds are red, so I know that the other ones are black. That's just how my brain works. Find a way to make that work for you. Okay? So let's try this. What's the probability of drawing a red card? Let's do this right here. Probability of a red card. What is my total? What are my total possible outcomes? 52, right? You're with me, right? 52? 52 possible. Okay, so that number, the big number, the biggest number, always in the denominator. Okay? What about the top? How many red cards do we have? 26. So it's 26 over 52. Can you reduce 26 over 52? Can you see that red cards is half of the deck? So technically this reduces to 1/2. I think we should be able to handle that one. Okay? What is the probability? This, honestly guys, this part right here, you don't need to do this part. It's just for you to know what are we doing. But if you just answered like this on an exam, full marks, okay? So what is the probability of an ace? It'll still be out of 52, right? How many aces are there? Oh, I should probably write this down because some of you don't play cards, right? I get it, because you have a phone these days. Like, why would you play cards if you have a phone, right? What do you play these days on your phones? What's that? Brawl Stars? Blackjack? Poker? Oh yeah, poker, yeah, I guess you still play poker. But on your phone, right? You don't feel the cards anymore. Guys, do you even know how to shuffle a deck of cards? Yeah. Anyways, this is an ace right here. This is from a casino, right? It's punched, right? Every time they play a game, they punch it, so it's no longer admissible. But that's an ace, right? Ace of spades, right there. But there's 4 of them, right? There's 4. So in this case, you would say 4 out of 52. Let's just leave it like that. Let's not simplify it. That's good enough. Okay, here's the cheat. Here's the cheat sheet entry. This is what I do. I just have a branch like this, and you might make this smaller. 26 black, 26 red. Okay. Then I branch off here, and I say that I have 13 clubs. You know what? I would say you probably can only go 13C, 13S, 13 hearts, 13 diamonds. Oops. Every single, what do we call these for? Suits? Have you heard of that? Suits? This is a suit, like there's 4 suits. Okay? And every single one has ace, 2 all the way to 10, and then followed by jack, queen, king. I think some of you need to just have this for every single suit. So one thing that I see students mix up, aces are not faces. See that? It even rhymes. Aces are not faces. So some students think they are, but they're not. Deck of cards is just a classic probability, right, example. What you can do here is this. These ones right here, there's 12 face cards. How many numbered cards are there? Numbered from 2 to 10. Let's do this up here. Look at the diamonds. This would be a numbered card. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbered cards. So 9 times 4, 36. So I'll write this down. 36. This is going to be tight. I'm just going to call it 36 numbers. I hope that tells you. And then 4 aces. That is it, guys. See? You can probably, some of you, your writing is amazing, so you can probably make this half the size and still read it, okay? So I hope that helps. So let's do a few more examples here. If I ask you for the probability of drawing a king, what would that be? Don't tell me, just write down the numbers as best as you can. Can you write those numbers down? They should all have 52 in the bottom, right, guys? You can get that much right, I hope. Your task is, I guess, to find what is the top number. So they should all have 52 because we're talking about a deck of cards. So there are no jokers. So they would remove me from the deck of cards. If I would be in there, I'm out, right? So try that. Let's see. I hope you wrote something down. Probably of grabbing a king. How many kings can you observe? And it talks about all of the kings, right? So this would be 4. Probability of a red queen. It's more specific. It's not talking about all of them. If you think red, you kind of just have to follow these two. There's only 2 red queens, so this would be 2. Black 4. You can't see it here, but it's intended, right? It's implied that this goes 2, 3, 4, and so forth. But there's 2 black 4s, right? Because there's 4 4s. That's kind of complicated, tongue twister. But 2 of them are black, so there we go. Ace of diamonds. How many ace of diamonds do you have? Just 1. It's specific. It's saying ace, so we're talking 4 at first, but it wants it to be of diamonds. There's only this one that meets the criteria, so it's 1 over 52. Okay, so hopefully that kind of gets you to understand how probabilities work. Could we have stated all of these as a decimal? Yes, we could have. Could we have done all of them as a percentage? Yes, we could have, but that's later. Okay, keep going. Here it is one more time. Probability. Make sure you follow along and you highlight a few things, and I would like you to transfer some right away onto your study sheet. The probability is the likelihood of an event happening. Probability of an event is here stated one more time. Okay. Here's where I need you to pay attention. I think I don't need you to worry about the notation, just about the concept. The probability of an event happening plus the probability of the event not happening is always 100% or 1. Okay? Let's see if I need to make sure you understand this. You should never have a probability that is bigger than 1 when you calculate it. Or you should never have a probability that's bigger than 100%. This is probability specific. When you're talking investments, your investment can grow to like 700%, 800%, 1,000%, because like it grows from where it is to whatever it ends up being, right? That's fine, but probability no greater than 100%. And let's see if this makes sense. If I tell you the probability of it snowing today is 60%, what's the probability of it not snowing today? If it's snowing is 60% and it not snowing, 40, right? I'm using easy numbers so you can wrap your head around it. So you see what I mean? If I give you the probability of something happening, you should know the probability of it not happening just by knowing that they add up to 100%. It's like supplementary angles. 2 angles that are supplementary add up to 180, right? We always know it adds up to 180. So 2 probabilities, it happening and it not happening, always 100%. So I will do this around it, and some notation here. Do you notice this little bar here? So E with a bar on top or E with a little tick means against, not happening. Okay? If you need to say not happening. So if F means Mr. Dirksen is funny, the probability of the joke being funny, then not F, right? You'd go F with a little bar on top, right? And then you'd know, oh, we're talking about the probability of Mr. Dirksen not being funny, right? So I'm not going to ask you what that is because I don't want to hear it, okay? The probability of winning, if a fair game has a probability of winning of 50%. That means that you will win half the time, you'll lose half the time. So we consider that fair. If you get 0% chance, it's impossible to win. If it's 100%, then it's certain that you will win. That would be a pretty good game to play, if you ask me. Okay, let's answer a few here. By the way, when it comes to probability, the key, oh, I'm gonna have to adjust my camera. This is classic, a die. You will see coins, a lot of coins. You'll see a lot of cards. And you'll see a lot of spinners. Get it? Spinners? I don't have a spinner right now, but you'll get a lot of those. Okay, so that's a staple of probability. And then you'll have everything in between, marbles in a bag, things like that. So just be aware of that. Here, there are 20 students in Mr. D's class. He knows that 7 of those students drive a car to school. State the probability of a random student driving to school in these 3 formats. So let's do that. I think by now you do know that. Probability of driving. You don't need this part when you answer a question. I'm just making sure you understand that because some students are thrown off by that. It just tells me what it is that I'm doing. So there's 20 students. 7 of those drive a school. So it'd be just 7 over 20. I go comma, listen carefully, I go comma to state the other one. This is why. If I go 7 divided by 20, it could be that this number goes on forever, like it never ends. It's an infinite decimal, right? If you say equals, you're rounding, so it's not exactly the same, okay? So that's why I would encourage you to just go 7 over 20, that's my fraction. Decimal is 0.35. And here's where some students are going to see this, like, oh yeah, just multiply your decimal by 100 and then you get your percentage. Not always. Only if it in fact is 0.35. Now, probability against, it says B, probability of a random student not driving to school. Probability of not driving. What would you, I think a lot of you would say, well, if 7 drive, how many are not driving? 13, boom. What's 13 divided by 20? Without doing the math, what would you say if we know 0.35 is driving, then 0.65 is not driving? Would you agree? Because that adds up to 1. But if you missed it, you just go and divide that, and you get 0.65, and then 65%. But I would say this, okay? If the question said 35% of the students are driving to school, how many do not drive? You should be able to come up with this without knowing the actual numbers. So this is the other method. Or 100% minus 35% gives you 65%. This is the other method of solving, okay? So not, we know that they add up to 100%, so we just subtract it happening from 100%, and away we go. All right, so I'm handing it off to you a little bit again. So I want you to go to page 6. And I want you to try those. I'm going to say 6 to 8. I was going to say 6 to 7, but it's getting old, okay? It's getting old. 6, so try pages 6 to 8. Before you do anything else, I want you to try at least these ones here before you go anywhere, okay? I don't care if you get it wrong right now. That's maybe part of the, so if I feel like most of you are done this, I will probably stop and just make sure we correct and we're all on the same page. Got it? So you want to use this spinner to answer these questions here. Okay, go ahead. And then keep going when you're done. Able to answer maybe other questions that you weren't so sure of. So if you wouldn't mind, just, yeah, since we're using this spinner, we're counting, and there's 8 sections, so all of these questions should have 8 in the denominator. And one thing that now I think you're going to be pretty good, but by the time we get to the exam, I still see a significant amount of number of students having a number bigger in the top than the bottom. You can't have that, okay? That is a problem. So probability of red, it's just as it sounds. There are 3 reds, so it's be 3 out of 8. Okay. Yellow, there's only 1 yellow there, so it's 1 over 8. Blue, there's 2 blue sections, 1 there, so it'd be 2 over 8. This means not yellow, right? Not yellow, basically. So you have 2 options. You count the number of sections that are not yellow, or you just go 8 minus 1. You've got your 7, right? So it's up to you how you want to tackle that. Not red. So basically we've got 1, 2, 3 reds. So watch what I'm going to do here. It's okay to do it this way. 8 minus 3. Okay, that means that there are 5 sections on the spinner that are not red. Anything else, any color, we just know that 5 out of 8 is not. When it comes to or, think of adding in math, right? So how many greens do we have? We have 2 greens, right? 2 green plus the yellow, which is, right, there's 1 yellow. And some of you just knew, like, I'm just going to add them up. It's 3 over 8. I know I'm not bothering with a fraction, with a decimal percent, but you should still do that. Blue or red. In this case, we've got 2 blues and we've got 3 reds. So that's 5 over 8. So at the very least, I would want you to have the fractions there done correctly. Okay? So hopefully that helped you. The next piece, which I really want you to have on your study sheet, guys, the reason why probability is actually very important when it comes to predicting what's going to happen in the long run, right? So for example, when they do polls for elections, do you think they ask every single person who they're going to vote for? No. They ask enough people. They make sure it's diverse, so they'll ask different parts of the city, right? They'll ask different age groups, so they'll ask the younger voters, the middle age, and the seniors, so they'll try to mix it up pretty good. But then they use that probability that they figured out to make a prediction on the larger scale, okay? So making prediction is very important. It's going to be something that you need to be comfortable with, where it's basically 2 components, right? I'm going to use 2 different highlighters. The first part is you need to figure out the probability of the event, and then you multiply it by the greater sample size, okay? So this is on a small scale. Now you're going to go on a larger scale. So this is how this works. If you were to spin the spinner above 350 times, how many times would it land on yellow? So we're going to go like this. Prediction is probability of yellow in this case. Multiply that by 350 spins. Okay, that's how we're going to try that. Probability of yellow is what? 1 over 8. I prefer the fraction if you can. Get it in here as a fraction. Because there was 1 yellow section out of the 8, you multiply it by 350. And if you get a decimal, you better round up or down, like a whole number. So we're going to go 1 divided by 8. Then I multiply that by 350. That gives me 4375. 4375. You can't have that when it's asking you how many times will it land on a certain region. So you got to go approximately. I would round this to 44. Either one is fine. Okay, approximately 43 or 44 times, according to this. If the wheel is spun 199 times, how many times would it land on red? We go probability of red times 199. Do we have probability of red up there? We do. 3 over 8. We multiply this by 199. So 3 divided by 8 times 199. That's 74.625. I'll write down the whole thing for now. So that's approximately 74 or 75 times. Okay, so that is how you do predictions. So when you go through these questions, they're going to ask you to do that, right? Based on the small sample, like how would that translate to a larger sample situation? The nice thing with a spinner, if it's unbiased, like a spinner could be biased, but you could tweak a spinner to land on a certain number, right? But if it's not tweaked, if everything is unbiased, right? We know that 3 out of 8 turns it will land on a red spot, right? If everything goes according to plan. Okay. All right. Keep going. 7 to 8. I'm going to ask you for. There's going to be some chocolates. Some of you probably had some of that over the break. I don't know if you've shopped for chocolate lately. Have you looked at the prices? It's crazy how expensive chocolate has become. And then page 8, okay? Attention on page 8, you need to refer to your deck of cards. I wanna make sure you get comfortable with a deck of cards. So if you need to go back to page, what was it, 4? Page 4 has a deck of cards. I'll just make a note here. See page 4. It should guide you through this, okay? And yes, I will encourage you to state your probabilities in all 3 forms, if at all possible. If right now you're like, you know what, I just want to make sure I get it right, just do the fractions for now and then do the decimals and percentages later, okay? All right, I'll stop talking for the next little while. You just go to town, pages 7 and 8, okay?